Uh, Good morning, everyone. My name is Chetan Kumar V. I'm a research scholar uh, in PES College of Engineering, Mandya. It is in state of Karnataka, India. I've been guided by Dr. D.R. Umesh, who is a professor, the Department of Computer Science and Engineering. So I'm at PES College of Engineering, Mandya. My topic of paper is an effective autism spectrum disorder sensory and behavior data collection mechanism using Internet of Things. Before getting into the actual paper, let us have an introduction on what exactly I'm working on. I'm basically working on autism, which is basically characterized as a neurodevelopmental disorder, which has severe effects on social growth and development in terms of children and adult. It basically generally has occurred due to the environmental factor or any other genetical disorders or linkages, which not only affects the nervous system, but also has an overall impact on social and cognitive skills of children and adult. A complete examination is actually needed to detect the ASD, comprising a thorough evaluation and series of assessment performance by the child health care professionals and psychiatrists. And also, early treatment and diagnosis of ASDs are crucial since they have somewhat lesser the symptoms, which enhances the person's overall quality of life. The machine learning basically uh, is one particular kind of mechanism or a platform wherein we try to do the analysis of certain data sets which are already available. ASD models are being analyzed in terms of less time and more accuracy using machine learning. Not only that, machine learning techniques are crucial for quick and accurate assessment of ASD risk and streamlining the entire diagnostic process, which assists the families in getting to the critical therapies more quickly. That is one point, and various classification models of machine learning can be used for early prediction of autism. Just to prevent its prolonged effects in adults as well as children. So that is the major criteria that we have taken here. And many other computational techniques has also been proposed in literature, such as proposed in IoT-based solutions for ASD detection and the present deep learning-based models for healthcare and ASD affected patients. Some of the literature survey that I have done and I've come to the conclusion is related to one author uh, by name is Zeb et al. They have actually introduced an enhanced distributed medium access control mechanism to ensure that a successful message delivery system wherein it considers node handover mechanism among the virtual cluster to ensure networking integrity, and also uses the concept of minimum connected dominating set for network formation to achieve the efficient energy utilization. Some of the advantages and limitations are like the model improved the packet delivery performance with better energy utilization. However, the model failed to bring the trade-off between the reducing the delay energy together. One more literature survey I would just highlight among some of the surveys which I've done is aiming to detect the ASD symptoms at different stages of ages with minimum time, controlled expense, and maximum accuracy. They actually provided the applications of federated learning technique for autism detection in children and adult by processing four different data sets by training SVM and LR. The advantages is the model achieves the decent ASD detection accuracy with improved data handling. However, the feature contributing to the ASD is not identified properly. Likewise, a lot of literature survey are being done, and major focus is on improvising the performance of the behavior of autism affected children by improvising the mechanism of data collection from the sensory data side. So that is one point that we are trying to focus on. So the research gap that we have found is the current work basically employing IoT for collecting the autism patient information, introduce the higher energy consumption and latency. The current ML-based methodology failed to identify which feature impacting the classification, the state of art data, the deep learning-based methodologies exhibits poor accuracy for small data set, and when data is imbalanced in nature, the traditional ML and the DL methodology failed to provide the good accuracy on similar kind of neurological or neurodegenerative disease detection. So this was the problem statement that I had defined in my research. So the proposed work aimed to design an effective behavioral data collection and supervised classification technique to accurately identify the ASD among young and adult using IoTs with better energy efficiency and less latency and more reliability. Some of the redefined objectives which are part of my research is develop an effective sensory information collection mechanism using Internet of Things environment. That is the main focus of my research, sorry, the paper which I'm presenting here. Uh, Developing an effective sensory information collection mechanism using an Internet of Things environment, the work will deploy a WBAN employing wireless sensor network where the user or the patient with ASD sends the sensory information to the nearby sinks and the gateway servers. The WBAN will usually be deployed as a community-based model. The data collection using the sensors can be done at special schools for children with ASDs. Here, the servers at special schools also keeps monitoring and tracks the ASD users, patients, and updates it to the main server. The BLE is used to identify the children and their location. The sensory data like kinematic and gait characteristics are periodically collected and communicated to the edge server. The current method, the methods employs clustering mechanism to improve energy efficiency for the data collection. The proposed data collection model mainly focus on using the Sensoria simulator. Basically, this simulator offers deployment for of different sensors with rich GUIs and baseline models to perform a good comparative analysis. So the ECR protocols will be used as comparative paper to compare the proposed model. This is one particular architecture which gives us clarity on how exactly the system works. So there is an architecture which is proposed as the high energy and reliable sensory and behavior data collection scheme, which includes almost the entire IoT system, the IoT gateways, the transmitter and the receiver, the base station. So whenever there is a movement that happens in the patient, the quality of the data which is being collected from one location to another location can be improvised by creating some of the clusters wherein the data collection process happens in terms of clusters rather than just sending the data directly to the base station. Whenever we consider the system as a whole, so the comparative study, which basically focus on what could be the outcome of this particular system. So the proposed model is expected to improve the energy efficiency of the data collection process, which is a major factor which affects the way in which the data is being collected and the data is being processed. So the data collected which are real-time data. So we have to make sure that the data which we have collected is as accurate as possible, because since we are trying to build this proposed system is purely a critical system, so chances of getting error should be as less as possible. So we are trying to make sure that we get the maximum number of accuracy, we achieve the maximum number of accuracy as possible. So the model will design an effective feature selection and supervised classification model to detect the ASD among children, young children, and adults in a more accurate way. So some of the work carried out, the existing system, wherein the studied performance of HERSBDC with baseline of LEACH and other recent routing protocols such as LEACH-Q and DECR is being used. So the Sensoria simulator has been used for conducting the simulation studies. The simulation parameters used for comparative study is being shown in this particular table. So we can go through that particular table. Some of the comparative analysis which we have got through comparison between the network lifetime and network lifetime and the device accuracy. So the following section examines the HERSBDC's lifetime efficiency using the standard LEACH as well as other currently used data collection strategies like DECR, which is distributed energy efficiency clustering and routing and LEACH-based. So you can see the network number of IoT devices which are being used and lifetime specification is being given over there. Routing overhead over device density. So the following section gives clarity between comparative analysis between the routing overhead and the device density. So the routing overhead is measured in terms of number of hops needed to carry out the data collection towards the IoT gateway server. Less value indicate basically the enhanced performance of the system. So you can see over here some of the representation. So these are the different comparative representation of the performance of the particular system of DECR, HERSBDCs, and the LEACH-based system. A comparative analysis between the delay and the device density. The following section actually gives that particular comparative analysis. So the delay in measure in terms of time taken to carry out the data collection towards the IoT gateway server, and less value indicates the enhanced performance. So you can see the enhanced performance of our system compared to the existing system. Future work to be carried out to design an effective behavioral data feature optimization to identify autism spectrum disorder among young children. The data collection from phase one are stored in cloud platform that should happen, and which can be later used to get the insight and assist users with ASD using the supervised learning approach. The model enhanced a mechanism to detect the autism spectrum disorder among adults using imbalanced behavior. The current ML-based method suffers when data is imbalanced in nature. So thus we are also focusing on poor features which are being selected, impacting overall ASD classification. We are also focusing on the model which will be tested on more robust kinematic sensory data sets like ataxia, Parkinson, and kinematic gait characteristics data sets to study the robustness of the proposed enhanced ensemble based mechanism which have been considered in machine learning specification. So this particular paper focus mainly on enhancing the way in which we collect the sensory data from which are real-time data from the autism affected people, and we try to make sure that the enhancement of that particular performance is being taken care at by and large in a better manner. So that is a major impact that we are looking out for in our particular system. So some of the references which we have gone through. Recent references are being taken up, and then the analysis are being done in that particular perception as well. So that's about my presentation. Thank you very much.